Lab 5, Choose Your Own Adventure by Justin Siegel. I decided to make my Lab 5 about drag, as I found it one of the more interesting topics over the semester. In this lab, I tested the motion of a falling normal piece of paper versus a falling crumpled piece of paper in the negative y direction. I chose these two objects as they are both very susceptible to drag or air resistance. Based on the data that I collected, two computational models were created using Newton's second law, both of which included gravity and drag. I then imported my first video into Tracker to detect the motion of the normal piece of paper. The length of the paper was used for reference, and I created an XY plane where the origin was the center of the paper at rest. The X and Y directions of the paper were recorded and graphed as it slowly moved in the negative Y direction. My second video was then imported into Tracker, and the X and Y motion were recorded and graphed. Next, I opened GlowScript and imported the starter code from Lab 2, as this code was the most useful. I kept mass constant as it would be easier to find the difference between the drag of the paper and the crumpled piece of paper. I also had to change the starting Y position, as that is the only direction we are going to monitor. I made sure to use the correct velocity and position update formulas, as well as update the arrow scales to make sure that they'd be facing the correct direction and be the correct size. The main difference between the two objects, the crumpled piece of paper and regular piece, was their B, or the drag coefficient. In order to find it, I had to use guess and check until the final position on GlowScript was the same as that on Tracker. The smaller the B, the more drag, or air resistance in this case, which is why the B for the paper is 0.00779 and for the crumpled piece of paper is 0.01. I ran the program side by side to compare the differences between the two. The blue arrow signifies drag and looks bigger on the crumpled paper, but because of that small green line on top of the normal paper, that means drag played a significant part in that experiment. For the position versus time graphs, the slopes are pretty similar as they started at the same position and ended at the same position in the y direction, and about constant velocities for each. For the velocity versus time graph for the crumpled paper, the velocity started out slow but got quicker as the ball was going down as it was accelerating. Now for the normal paper, there was acceleration at the beginning due to air resistance, but quickly all acceleration went away as air resistance took full effect as the paper slowly floated down to the floor. For my results, I found that for the normal sheet of paper, that the velocity or position versus time that was expected was much greater than the actual position versus time. And this is due to my error and due to the fact that I only accounted for the paper in the y direction. In reality, the paper turned in circles and swayed back and forth in the x direction, which would take a lot longer than if the paper just went straight down, which is what the expected position versus time graph was actually looking for. Now, for the crumpled paper, the actual and expected velocities and accelerations were very similar. This is due to the fact that drag was accounted for in our GlowScript, as well as there's actual drag in real life. The only issue was that my human error happened and the ball was not actually dropped straight down. There was some movement in the x direction, and there's other external factors in this room which could have affected the movement of the crumpled piece of paper as well as the normal sheet of paper, which is why the expected were not exactly correct like the actual, but very similar. Thank you for taking your time to view my Lab 5, Choose Your Own Adventure.